Now, our next question is integrate the integral from 0 to 2 pi of 2 cos 2x dx. Integrate this integral, that is from 0 to 2 pi. So the function that you're integrating is 2 cos 2x dx. Now, 2 cos 2x dx. Now, here, our solution will be, let's say, solution. First we say, let u be this. Let u be this, which is 2x. Now, having let u to be 2x, this should then mean that du dx is equal to 2. If you differentiate u with respect to x, you get 2. And we can write this as, which is also equal to, that's also equal to du is equal to 2 dx. So we can as well say that du is equal to 2 of dx. What that means, what again that means is that dx is equal to du over 2. Yes. So if I let u to be 2x, I'm just dealing with this part. And if then I differentiate u with respect to x, then I end up with 2. But that simply means that du is equal to 2 dx. And so dx is equal to du over 2. It then means that where there is dx, I can put du over 2. But then let me see what I had. I can then write this integral. I can write the integral as, let me see. It will be from 0 to 2 pi. 2, let me just factorize this 2, I bring it outside. Then I say, realize that u is 2x. So where there is 2x, I'll put u. So I'll say 2 into cos of u, and where there's dx, I put du over 2. Du over 2, like that. This brings me here, so that I have, if the integral is 0 to 2 pi, that is now, that should be a complete, that's one period, should be one period. Then we then have cos u du, because this two cancels that other 2. So I have 0 to 2 pi of cos u du. But then we know that if you get this particular integral, this integral here is going to be sin of u plus c. Sin of u plus c. Of course, we give the limits of 2 pi and z as such. And that gives us, but what was u? U was 2x. So I can as well say it's the integral of sin of 2x plus c, and we give the integral 2 pi, that is between 0 to 2 pi. That is sin of 2x plus c, and we give it, we find it within these limits. But then, what do we have as, sin? Because now, if we are substituting where there is x, we put this. And where there is, okay, the first case will be, this will then be, this will be sin of now, where there is x, we put this. It then means we are talking about sin of 4 pi. So sin of 4 pi minus sin of 0 is just equal to 0 minus 0, which is 0. Of course, by subtracting, when we substitute this, okay, first we substitute this here, and there's just that c. Then we substitute here, and there's just that c, but we subtract. Upon subtracting, c and c will cancel out. Then we end up with 0 minus 0. We end up with 0 minus 0. So sin of 4 pi is 0, minus sin of 0 is also 0. So we end up with the 0. So this integral, the entire integral as you see it, reduces to 0. It then means that if you draw this function here, the area under it between the point 0 to 2 pi will be no area. So it means there's no area under that particular curve. So I think there's need to draw it so that we see how you can end up with an area which is 0. But for now, let me stop at that. Should you wish to know more about similar functions and how to go about them, then I would urge you to visit our website. Our website is this. www.MEF of MEF school.co.ke. That's it. If you visit that site, then you will be able to find options where you can book a class with us directly at your convenience. And the beauty again is that you'll be able to choose the topic that you'd want us to consider. So up to there, I want to stop this at that. And I hope we followed. The main trick is, if you are to integrate this, then you should have understood first that you need to factorize this. Having factorized that, you end up with cos of 2x. This again is composite, and that's why we are bringing in the reasoning or the argument of the chain rule. And that is where we have let then u be this, and we go about it as I've explained up to there. So up to there, see you in my next video.